A very common integral that we see quite often is when we have the integral of one polynomial divided by another polynomial. Now, whenever we see that, our mind usually drifts towards like log rule, and that's a good thing. That's a good idea to try. But the problem with log rule is it assumes that if these are both polynomials, the numerator would have degree 1 less than the denominator so that you can get that pattern of du over u. For example, you might have a quadratic over a cubic, right? And that would fit because 3x squared would be the derivative of x cubed. When you differentiate powers of x, the power goes down by 1. But when you have a situation like this, if you notice, the degrees don't go down. You have x in the numerator and x minus 6 in the denominator, and something's just not quite right. If x minus 6 is your u, then just 1 would be your du, not a full-blown x. So whenever the numerator here's degree is the same or larger than the denominator, we're in trouble, right? If it's anything other than just 1 less than the denominator, it's not going to be immediately a log rule problem. So what do? Well, this one's actually, at least starts off as a long division problem. See, what you do is if you have the numerator larger or the same degree as the denominator, we'll divide the denominator into the numerator, and that's called long division. It's an algebra procedure. All right, so let's do this real quick. What we're doing is we're dividing literally x minus 6 into x. And just as a reminder, remember we need placeholders for the dividend anytime you use long division. So here we go. We ask ourselves, what times x minus 6, or namely just the x, would give us at least just an x? We'll worry about the constants later. And the answer would be 1. 1 times x gives you x. So I'll put a 1 in the numerator, or not in the numerator, but on the top of the fraction bar here. But let me put it in the right place. I don't want to put it here because this is the column for x's. I'm going to put it in the column for the constants. I'll put it right here. All right, and then just as if these were two numbers that we were using long division for, we'd say 1 times x minus 6 equals x minus 6. And I'll put that product right here. Now I'll draw a line, and we're going to subtract. But when we subtract, we're going to subtract both this column and this column. So make sure we do it correctly. X minus x is 0. 0 minus negative 6 is actually plus 6, right? This guy here, as we all know, is called the remainder. The number 1 up here is called the quotient. The x minus 6 right here is called the divisor. And the x right here is called the dividend. So same phrases, same vocabulary that we learned, back in middle school even. I mean, a long time ago when we were learning long division of numbers. Now, how does this help us? Well, the main thing it helps us do is rewrite x divided by x minus 6. Now, how does it do that exactly? Well, let's take a time out for a second. Let's look at a number analogy, and maybe this will help us. So if we were doing 7 divided by 4, and I wanted to rewrite this as like a decimal or something, then I would literally have to divide 4 into 7. 4 goes into 7 once. Excuse me. 1 times 4 is 4. We subtract, we get a remainder of 3. Now, what do? Well, the meat of the answer is the quotient. 1 is the meat. Now, how do we take the remainder into account? Do we say that 7 divided by 4 is 1 plus the remainder? No, certainly not. No, it's the remainder as a portion of the divisor. So 7/4 is equivalent to 1 3/4, or 1.75. So we're going to do the same thing, only with polynomials. So the meat of our answer is the quotient. That's the major part of this fraction here. So x over x minus 6 mostly is the number 1. Now we did have a remainder of 6, but what do? Do we just say 1 plus 6? No, again, it's 6 out of the divisor, right? 6 out of the divisor as a portion of the divisor, which was x minus 6. So it's the same pattern here. So these two are equivalent. Now, why do I care? Well, if you're trying to integrate this guy, and it's very difficult, would it not be a lot easier to integrate the number 1? Oh, much so. And integrate this guy, which is clearly a log rule. Yes, I would much prefer to integrate this over here. And so that's why we use long division. All right, so if we come back up here, then the integral of x over x minus 6 would be the same as the integral of 1 plus 6 over x minus 6 after long division, which will be integral of 1 is x. And this guy right here is a straightforward log rule. So if you haven't watched any of the other log rule videos, you might need to watch those first, because this one wouldn't be a good first introduction to log rule. I've got other videos that kind of explain how the log rule works. So without going into a lot of detail, you can work out the details on your paper. This guy's integral would be 6. We would pull out the 6, the constant here, times the natural log of the absolute value of x minus 6. And obviously we would have a plus c on the end, being an indefinite integral. So a lot of these indefinite integrals, you have to do lots of rewriting before you even get to the integration. But the good news is usually after all this rewriting and you've got it primed and ready, then the integration is actually much smoother. But you're very limited in the amount of rules that we have for integration. So you just have to be a lot more clever and use a lot more ingenuity to do a lot of these integrals.